Okay, so now that we've seen how to simplify rational expressions, today we're going to look at how to multiply and divide rational expressions. So really quick, just a quick reminder of how we multiply and divide fractions because this follows the same rule. So if we multiply fractions, if I have 1/2 times 2/3, we just multiply straight across. 1 times 2 is 2, 2 times 3 is 6. We simplify from here and we get 1/3. Okay, when we're multiplying fractions, I'm going to back up for a second. We also have the option, if we want to simplify before we multiply, we can. So we can simplify anything from the numerator with things from the denominator. So notice here, I have a 2 and 2 in common, one on top, one on bottom. Those can cancel. And I'm still left with 1/3. So we can either simplify at the beginning or at the end. A lot of times I think it's easier to simplify at the beginning because then we're working with smaller numbers. Okay, when we are dividing with fractions, like let's see, if I have 1/2 divided by 2/3, don't forget your rule from way back when. When we're dividing by fractions, we keep, change, flip. Another way to say that is we multiply by the reciprocal. So for my problem, I keep the 1/2, I change to multiplication, and I flip this fraction. So we're multiplying by the reciprocal. So if we do that, 1 times 3 is 3, 2 times 2 is 4. We can't simplify, so our answer is just 3/4. So that's kind of the foundation of what we're doing today. Now our problems are just going to look a little bit more complicated here. Okay, example 332, there's actually no variables here. This is kind of like an example like the ones I just showed you. We just have bigger numbers. So by all means, if you have your calculator with you, you could multiply what's on top, you could multiply what's on bottom, simplify from there. Just type it in your calculator, math, enter, enter. But I'm going to show you how we could simplify beforehand to make these numbers a little bit easier to work with. If we look at this 15 and 45, we can divide both of those by 15. 15 divided by 15 is 1. 45 divided by 15 is 3. And for our other diagonal here, we have a 14 and a 49. Both of those can be divided by 7. 14 divided by 7 is 2. 49 divided by 7 is 7. So now we have a lot smaller numbers to work with here. On top, we have 1 times 2 is 2. 7 times 3 is 21. And that cannot be simplified. You would get the same answer if you multiplied 15 times 14, 49 times 45, and then just simplified those big numbers. We should end up with the same thing if we do it correctly. I just generally try to simplify anything I can first, just to make my numbers easier to work with. Okay, on 333, same process here, but we have some variables. Again, I'm going to try, here, let me draw my fraction. I'm going to try to simplify some of my numbers so that I have smaller things to work with. All right, so I have a 25 and 55. They can both be divided by 5. I get a 5 here and an 11 here. 24 and 9 can both be divided by 3. I get a 3 here and an 8 here. And then if it gets a little bit messy, you can try to cross cancel some of your variables too, but if that's too messy for you, let's just see what we have and then we'll work with our variables and exponents. On top, 5 times 8 is 40. We have x squared, y to the 4th. On bottom, 3 times 11 is 33. We have x to the 7th, y to the 8th. And notice I just switched the order of those, so my x's would be stacked, my y's would be stacked. All right, so now if we go ahead and keep dividing from here, we can't simplify 40 over 33. We could try it, type it in, math, enter, enter. But if we simplify our variables with our exponent rules, when we're dividing, we subtract exponents. 2 minus 7 is -5, so I'm going to go ahead and move that to the bottom. It becomes +5. For my y's, 4 minus 8 is -4. Move it to the bottom. It becomes +4. So we get 40 divided by 30x to the 5th, y to the 4th. All right, so let's do one division here. So we said when we are doing division, we multiply by the reciprocal, or we keep, change, flip. What I mean by that is we keep our first fraction, we change it to multiplication, and we flip our second fraction. You could simplify from here, or we could multiply straight across first and then simplify. On top, I get 4a to the 4th b squared divided by ab to the 4th. Nothing to cancel that 4 with, so I'm just going to leave it on top. For my a's, 4 minus 1 gives me a to the positive 3rd power. For my b's, 2 minus 4 gives me b to the negative 2nd power, or I can move it to the bottom and it becomes b to the positive 2nd power. Okay, so all of those so far, we are still just working with monomials. We have one thing on top, we have one thing on bottom. If you look at the next couple examples, we have polynomials. We have some binomials and trinomials on top and bottom. So when you see this, do not just multiply straight across. You're going to end up with something super complicated that's going to be hard to work with. So when we are multiplying rational expressions like this, it's going to be easiest if we factor first. Then we're going to simplify common factors. We're going to look and see if there's anything the same on top and bottom, and we're going to cancel those out. So let's take it piece by piece. A lot of factoring practice here. X squared minus 9. That's the difference of squares. That factors to be x plus 3, x minus 3. On bottom here, we're trying to think of two numbers that multiply to be negative 20, add to be positive 1. That should give me x plus 5, x minus 4. Okay, same thing on this fraction. Two numbers that multiply to give me 16, add to give me negative 8. I'm going to get x minus 4, x minus 4. And on bottom here, there's not a quadratic. All we can do is take out a greatest common factor of 3, and I'm left with x plus 3. All right, we got a lot of binomial factors here. Let's see what we can cancel out. We've got an x plus 3 on top, x plus 3 on bottom. We've got an x minus 4 on top and x minus 4 on bottom. And that looks like our only common factors. So we're left with, on top, we're left with an x minus 3 times an x minus 4. And on bottom, we're left with an x plus 5 and then a 3. And I'm going to stick that 3 on front just because that's where we generally see it. There's no other common factors. Notice here we cannot cancel terms, only factors. So we leave it just like this. If you wanted to, you could multiply those out just to write it as a quadratic trinomial, but there's really no need to. We can leave it factored. All right, and then our last one here, notice we have division. So we're going to keep, change, flip. Just like we did with normal fractions. So as I rewrite this keep, change, flip, I'm going to go ahead and factor it just to save me having to write it out 2 times. So for the first one, if I factor this, I need two numbers that multiply to give me negative 12, add to give me negative 1, x minus 4, x plus 3 works. On bottom, this one, multiply to give me negative 8, add to give me negative 2. I should get x minus 4 and x plus 2. Okay, I'm going to change it to multiplication, and I'm going to flip this second fraction as I factor it. So on top is really going to be this thing. If I factor that, two numbers that multiply to give me negative 2, add to give me 1. I'm going to have x plus 2, x minus 1. And then I've got this thing on bottom. It looks like I can just factor out a 5x. If I do that, I'm left with x plus 3. All right, so we did keep, change, flip. Now we're going to cancel common factors. We've got a common factor here, x plus 2 on top and bottom, x plus 3 on top and bottom. So the only thing we're left with on top is an x minus 1. The only thing we're left with on bottom is a 5x. And again, we cannot cancel these x's because this is a term, not a factor. If our problem looked like this, hey, now we could cancel those x's because they're factors, not terms. But our problem did not look like that, so we just stop right here. X minus 1 divided by 5x. And then our last example here, working with multiplication and division. Notice we have multiplication and division happening. So I'm going to kind of factor all of this. For this last part, remember, keep, change, flip. I'm going to change this to multiplication. I'm going to flip this fraction. So let's do, we got a lot of factoring here. Let's do this first one. Multiplies to give me 10, adds to give me 7. We have a plus 5, a plus 2. On bottom, multiplies to give me 5, adds to give me 6. We have a plus 5, a plus 1. Okay, that top can't be factored. We just have a plus 1. On bottom, multiply to give me 4, add to give me 4. We have a plus 2, a plus 2. And then our last one, these can't be factored, so we're just going to flip it. We're going to put that a plus 2 on top and that a minus 1 on bottom. All right, now let's start looking for our common factors. On top and bottom, we have the same thing. A plus 1 on top, a plus 1 on bottom, a plus 2 on top, a plus 2 on bottom, another a plus 2 on top, a plus 2 on bottom. All right, so this thing simplified a lot. There's nothing left on top, so we're just going to put a 1. And we just have an a minus 1 left on bottom. So we started out with this giant thing, and it simplified down to this. It simplified down to 1 divided by a minus 1.